In this section, we will use what we have learned before about exponentials to define polynomials, learn about them, about their properties. Terms and coefficients. In an expression such as this one, the terms are, so in this case we have four terms, 4x cubed, 6x squared, 5x, and 8. These are called the terms of the polynomial. The term that has the largest exponent, largest power, is called the leading term or the first term. The numbers 4, 6, 5, and 8 are the constants that multiply the x's that are raised to powers. So we have in the first case 4 multiplies x raised to the power 3. In the second case 6 multiplies x to the power 2, 5x. The last one, you can think of it as 8 multiplying x to the power 0. These constants, these numbers, are called the coefficients of the terms. So the coefficient of this is 4, coefficient of this is 6. More precisely, we think of the 4 as the coefficient of x cubed, and 6 as the coefficient of x squared, and so on. This term is usually called the constant term. Name the coefficient of each term in the expression. Give the number of terms. In this expression, we have two terms. We have 2x cubed and we have minus x. The coefficient of x cubed is 2. The coefficient of x is minus 1. Like terms have exactly the same variables with the same exponents on variables. So only the coefficients may differ. For instance, these two terms are called like terms because both of them, they have m to the power 5, which basically means you can add and subtract these two terms. Similarly, we have y9, y to the power 9, and y to the power 9. So these are called like terms. So you can add 6y to the power 9. You can add them to minus 37 of y to the power 9. And you can add or subtract 1y to the power 9. The idea is if you have, let's say, 2y to the power 9 minus 3y to the power 6, you cannot add them. Okay. These are y to the power 9 and this is y to the power 6. You cannot add them. So that's why we say these are not like terms. These are also like terms because here you can say we have 3p times q, and here we have minus 2p times q. So we can add them, subtract them, and so on. So that 3pq minus 2pq is equal 1pq. So we consider these to be like terms. These also are like terms. Okay, you have xy squared. Xy squared. So these are considered like terms. So for instance, we can add them. 2xy squared minus 1xy squared equals 1xy squared. But 2xy squared and let's say 3x squared y are not like terms. 2xy squared and 3x squared y are not like terms. They are not the same kind of terms, so we cannot add or subtract them. 7x and 7y are not like terms, so they stay as is. You cannot add them. Okay, think of them as 7 apples and 7 oranges. You cannot add them. You can put them together, but you cannot add them. So you can say 7x plus 7y. You can put them together, or 7x minus 7y, but you cannot add them. On the other hand, if you have 7x plus 7x, you can add them. Not only you can put them together, but you can also add them. Z to the power 4 and z to the power 1 are not like terms. 2pq and 2p again are not like terms, and this is something I already mentioned when I was talking about the last of the like terms. Simplify by combining like terms. In this first expression, we have these two are like terms, so we can add them. 1r squared plus 5r squared is 6r squared, and 3r, there is nothing we can do about it. And the second one, b, there is nothing we can do about this. We don't have like terms, so this stays as is. A polynomial in X is a term or the sum of a finite number of terms of the form ax to the power n for any real number a, so these are the coefficients, and any whole number n, these are the exponents. So it has to be a finite number, not infinite. So a could be any real number, and x could be raised to any whole number. Any whole number, it means x can be raised to the power 1, to the power 2, to the power 3, blah, 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 and x to the power 0, which is 1, which means we can have a constant term. So for instance, since a could be any number, let's say a could be radical 2 x to the power 3 minus 5x to the power 2 plus 3x to the power 1 minus 16x to the power 0. And that is the constant term. Okay, so this is a polynomial. The coefficients, the a's are real numbers. It's minus 5 in this case. And the exponents, the n's, are whole numbers. So it could be 3, 2, 1, and in this case, 0. All right. The degree of a term is the sum of the exponents on the variables. The degree of a polynomial is the greatest degree of any non-zero term of the polynomial. So for instance, if you look at this term, the degree is 4. It's the exponent 4. And a polynomial with degree 4 is a polynomial that has x to the power 4 as the largest exponent, has 4 as the largest exponent. Okay, so this is a polynomial of degree 4, because first it is a polynomial. It has the coefficients, real numbers, and it has x to the power n. Okay, in the first case, x to the power 4, in the second case, x to the power 2, and in the last case x to the power 0. The second one, this is a polynomial, 5x plus 5. The largest, the leading term, the term with the highest degree, is 5 times x to the power 1. So the degree is 1. So this is a polynomial of degree 1. This is a polynomial in 2 variables, and you have x squared y plus xy minus 5y squared. All right. In this case, it looks like there is a mistake here. In this case, the degree is here. The degree has to do with the variables, right? The variables raised to whatever power. This is x to the power 2. This is y to the power 1. So this term is a third degree term. Then the second one, x to the power 1, y to the power 1, so it's a second degree term. And the last one is y to the power 2, so it's a second degree term. The largest one is this. So this is a third degree polynomial. Okay, it's very important to notice here that this is a polynomial of 2 variables, or in 2 variables, x and y. So this goes actually here. Now, the degree of this polynomial is 3. So this is the degree of that polynomial. This has no place in here. Finally, we have this polynomial. Okay, you have x to the power 5, and then you have x to the power 6. So this is the leading term, the term with the largest exponent. The degree of this polynomial is 6. If you have a polynomial, let's say like minus 16, this is a polynomial. This is degree 0. I think this is what they meant over here by that. Okay, so this is degree 0. Because you can think of this as minus 16 times x to the power 0. Degree 0. Vocab. A polynomial with only one term is called a monomial. Monomial. Mono means one. Okay, so this is a monomial, 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 monomial. A polynomial with 2 terms, 2 is a binomial. Bi means 2. So there are 2 terms. Okay, this is a polynomial that has 2 terms, this and this. Again, this is a binomial because it has 2 terms. This is a binomial because it has 2 terms. A polynomial with exactly 3 terms is called a trinomial. Tri means 3. 3 terms, trinomial. 3 terms, trinomial. 3 terms, trinomial. This is of degree 2. This is of degree 2. This is of degree 5. This is of degree 1, monomial. Monomial of degree 5. Monomial if a is considered in this case a variable, it's a monomial of degree 2. If a is considered a constant, most likely here they mean it's a constant. So this is a monomial of degree 0 because this is a constant. Okay, we think of it as a squared times x to the power 0. This is a monomial. 6 is a monomial of degree 0, 2. Simplify, give the degree, and tell whether the simplified polynomial is a monomial, a binomial, a trinomial, or none of these. Okay. This polynomial cannot be simplified, so it stays as is. We don't have like terms to worry about. And this is the coefficient. This is the term with the largest exponent, degree 3. So this is a binomial because it has 2 terms and it is of degree 3. Here we can simplify. All of these are like terms. So this is 12x minus 14x is minus 2x plus 3x is equals to x. So this is a monomial. The coefficient is 1 and the degree is also 1. This is to the power 1. This also can be simplified because we have like terms. 6xy minus 7xy is minus xy plus minus xy plus 3xy is 2xy. The coefficient is 2 and the degree is x to the power 1, y to the power 1. So you have 1 plus 1 is 2. The degree is 2 and it is a monomial because you have, after simplification, you have only one term. Find the value for y equals minus 1. Okay? In these polynomials, whether you have x, y, m, n, or whatever, the variables are quantities that can assume different values. So in this case, we have a polynomial of degree 3, which is a trinomial. Now this can have different values depending on what the variable y, what value we assign to the variable y. Now, if we assign the variable y a value of minus 1, then for every occurrence in the polynomial of y, we replace it with minus 1. So this becomes 2 times minus 1 to the power 3 plus 8 times minus 1 minus 6. Minus 1 to the power 3 is minus 1. Minus 1 times 8 minus 6. So this is minus 10 minus 6. So that's minus 16. So this polynomial has a value of minus 16 when y has the value of minus 1. Now, of course, if you give y a different value, then the polynomial will assume a different value. We add polynomials by adding the like terms. For instance, if you want to add this polynomial to this polynomial, you look at the like terms. So this is cubed, can be added to this. This square can be added to this square. And finally, this x can be added to this x. So 4x cubed plus 6x cubed is 10x cubed. Minus 3x squared plus 2x squared is minus x squared. And 2x minus 3x is minus x. And the result is this. This is the result of adding these two polynomials. All right. Add this polynomial to this polynomial. Start with the first one. You have x squared, and here we have x squared. So let's call the first one p1 of x, the second one p2 of x, polynomial of x. So x squared plus 4x squared is 5x squared. Now, minus 2x, there is no x here, so we keep it as is, minus 2x. Or you can think of this second polynomial as 4x squared plus 0 times x minus 2. So in that case, we add the x with the x. Minus 2x plus 0x is minus 2x. And then we have the 5 with the minus 2. 5 plus minus 2 is 3. So this is the sum of the two polynomials. Again, we add. The blue ones are like terms, x to the power 4. The green ones are like terms, square, and the red ones are constants, power exponent 0 if you like. So 2x4 minus 3x4 is minus x4. Minus 6x squared plus 5x squared is minus x squared. And 7 plus 2 is 9. So the sum of these two polynomials is this polynomial. The result is always a polynomial. Now, subtracting polynomials is the same as adding numbers, right? If you want to subtract 6 minus 3, it's the same as 6 plus minus 3. All right, so you just multiply this by minus and you add. We do the same thing. We look at the polynomial to be subtracted. It's called subtrahend. Okay, I don't think you will ever use this term. And multiply it by minus, and then we add. All right, so this minus this. So first what we do is we multiply each term by minus. Okay, so we have 7y squared minus 11y plus 8 plus minus minus, that's 3y squared, minus plus, that's minus 4y, and minus plus is minus 6. So now we look at like terms. This plus this is 10y squared minus 11y minus 4y is minus 15y. The constant terms 8 minus 6 is 2. All right, subtract this from this. So this is the one to be multiplied by minus. Subtract this from this. So we write 14y cubed minus 6y squared plus 2y minus 5 plus multiply each term here by minus. Okay, so here we already have the multiplication by minus. Okay, it's very important. It's this minus this, because we have to subtract this from this. So 14y cubed minus 2y cubed is 12y cubed minus 6y squared plus 7y squared is 1y squared. 2y plus 4y is 6y, minus 5 minus 6 is minus 11. Okay, subtracting polynomials, we're subtracting this from this. 14, okay, we already did that, so I'm not going to do that again. I don't want to talk a lot about this in practice, and later on we will never, well, we will look at this, but it's the same thing. You can put them next to each other and subtract, or you can put them on top of each other like over here and subtract. When you do it this way, you put like terms on top of each other. So there is no y term here. So we say plus, if you like, plus 0y. And there is no 0 term here. So we'd say plus 0. So this minus this. So here minus 0y is not going to make a difference. And here plus 0. So this minus this is 12y cubed. This plus this minus 6 plus 7 is plus y squared plus 2y, because 2 minus 0 is 2, and 0 minus 6 is minus 6. All right, subtract this from this and then add this to the result. Fine. Put this over here. Then multiply this by the minus. Okay, it's over here after multiplying by minus. And place this next to them over here. And we look at the like terms. Power 4, power 4, power 4. So 3 plus 2 is 5, plus 1 is 6, t to the power 4. Power 3, no power 3, no power 3. So just 7 t to the power 3. Power 2, there is no power 2 here. Power 2 only 1, no power 2 here, so minus 3t squared. T minus 8t, no t here, minus 6t, so that's minus 14t. Constant term, 3 plus 6 is 9, plus 6 is 15. Again, this minus this, so we put them next to each other. This is the first one. Then the second one, you bring in the minus sign. So we have this, and look at the like terms. This is the same as this, so 5 minus 7, so minus 2 m cubed n. M squared, n squared, m squared, n squared. So 3 plus 1 is 4. Mn, mn. 6 minus 4 mn minus 6 mn. So minus 10 mn. When we graphed straight lines, okay, straight lines look like this, or y equals ax plus b. Okay, it was a polynomial of degree 1, so we graphed those. We learned how to graph those polynomials of degree 1. Polynomials of degree 2, okay, it will always have this shape. X squared will look always like this. Now 2x squared, it means we're having larger y values for the same x. So 2x squared means it's going to be stretched vertically or shrunk horizontally. So if this is 2x squared, the one that we have, x squared will look something like this. Will be a little bit wider. Okay, so this is x squared.